Okay, with it. Now we can start today's session. Up to now, we have discussed some parts in vectors. So today we are going to discuss, as a first lesson, today we are going to discuss resolving of a vector. Okay, they write a topic. Resolving of a vector. Resolving of a vector into two perpendicular directions, into two perpendicular components, into two perpendicular components, into two perpendicular components. Okay. Today, this is the reverse process of taking the resultant force. Okay. Suppose everyone, please listen to me. This is very, very important lesson because resolving of a vector. Actually, that knowledge will be applicable in any unit of physics. Therefore, most of the units may in physics. Therefore, you have to understand this one very well. Okay. Resolving means that is the opposite process of taking resultant. So suppose you are given two perpendicular vectors, Q and P. Okay, if you are given this kind of two perpendicular vectors, then these two vectors can be replaced by its resultant vector. No, these two vectors can be replaced by its resultant vector. So what is the meaning of resultant vector? Resultant vector means that is the vector that can give the same results as the vector system. Now this is the vector system. So resultant vector means the single vector that can give the same result as the vector system. Okay. Therefore, we can replace these two vectors by its resultant. This is P, this is Q. So how to take the resultant? If you complete the vector parallelogram, then we can take the resultant. If you complete the vector parallelogram, then we can take the resultant. So this is the resultant force. This is the resultant vector. Therefore, instead of these two vectors, this vector system is equivalent to a vector polar. Therefore, this vector system is equivalent to this vector. And is that clear? If it is clear, please raise the hand. This vector system is equivalent to this vector. And that means, Puthe, this vector and these two vectors are equal. This vector and these two vectors are equal. Therefore, we can do this reverse process. We can do the reverse process. We can argue in reverse way. We can build an argument in reverse way. Like, Well, these two vectors are equal to this one. That means this vector is equal to this one. That means we can represent a vector using two perpendicular components. So instead of a single vector, we can use two vectors in two perpendicular directions. So what is the requirement of that? What is the requirement of that input? The requirement is like this, Puti. So if you are given this kind of vector, the direction of that vector is unknown. Is unknown. Unknown ways it is very difficult to define the direction. No, very difficult to work with the direction. Therefore, in such cases, we can use two perpendicular vectors instead of this one. So suppose suppose we know the vertical and horizontal. Suppose we know the direction, vertical direction and the horizontal directions. So in such cases, instead of using a single vector, I can use two perpendicular vectors into non-direction. So actually resolving of a vector is very much used to deal with the direction of the vector. ඒ කියන්නේ vector එකේ direction එකත් එක්ක deal කරන්න තමයි මම මේක use කරගන්නේ. මොකද මේ වගේ වෙලාවක actually it is very hard to deal with the direction of the vector. But if you resolve this vector into two perpendicular direction, then I know this q vector is into vertical direction, this p vector is into horizontal direction. Then I know the magnitude as well as the direction of those vectors. Okay. Therefore, this process is called taking resultant vector, and the opposite process is called resolving of a vector. Resolving of vector. Therefore, this single vector R is equal to two perpendicular components. Two perpendicular components P and Q. Therefore, when it is necessary, we can represent this single vector R by two perpendicular components. Two perpendicular components which are called the resolving component. Resolved components of R. Resolved components of R. Is that clear? If it is clear, please raise the hand. Okay. Now you can draw this one. I finish. Once you finish, please give me a thumb. அடுத்தது. Okay, they write this. Write on this. Two perpendicular vectors can be represented by its resultant vector. Two perpendicular vectors can be represented by its resultant vector. That means the resultant vector within the brackets capital R. That means the resultant vector capital R, close the bracket. The resultant vector within the brackets capital R. That means the resultant vector is equal to 2. The resultant vector is equal to two perpendicular vectors. Two perpendicular vectors. Write in another para. Therefore, any vector can be represented by two perpendicular vector components. Can be represented by two perpendicular vector components. That process is called resolving of a vector. That process is called resolving of a vector. Underline that word. Underline the sentence. That process is called resolving of a vector. That means this, suppose you are given this kind of vector. So you can resolve this vector into two components. One is in this direction, Other one is in this direction. Other one is in this direction. And into two perpendicular components. So these are called resolved component. Resolved components. When you are resolving a vector, definitely you have to resolve that vector into two perpendicular components. So sometimes actually, if you can resolve a vector, into two another components which are not perpendicular, that also possible. But the main problem is it is very hard to determine the vector components. So you definitely have to apply your trigonometric knowledge and geometric knowledge to solve such kind of thing. Therefore, we are not given such kind of questions. So we are given only perpendicular directions. Therefore, a vector can be resolved into two components in any direction, but according to our syllabus, we are given only two perpendicular directions. And perpendicular directions can but that is the easiest way. Actually, the requirement of resolving is taking the direction easily to put it. Therefore, the most easiest directions are two perpendicular directions. And otherwise, again, it will be very hard to take the resolved components. Therefore, that is not necessary. Anyway, for your knowledge, remember, resolving can be done in any directions, but for convenient purpose, it is very convenient if we can resolve a vector into two perpendicular directions. That's all. Okay. Anyway, if you resolve a vector into two perpendicular components, definitely there are two components with it. Therefore, you cannot resolve a vector into single direction. That is very wrong. That is wrong, Pute. So, a vector is equal to two perpendicular vectors. And therefore, you cannot resolve a vector into single direction. That cannot be done, Pute. And this vector is not equal to this kind of vector. These two are not equal because directions are different and the magnitude also different. Therefore, you cannot resolve a vector into single direction. Okay? Therefore, when you are resolving vector, there should be two vector components. Definitely, there should be two vector components in perpendicular directions. Then you can remove this vector and take the other two vectors. Okay. If you resolve this vector into two perpendicular components, then you can replace this vector by these two components. Then no need of this vector. And vectors or you cannot use all three vectors. Once you resolve the vector, then instead of this vector, you can replace that vector by Q and P. Okay. Now we can determine how to take those components. And components actually we can use the same method, which is called vector parallelogram law. And now we have to resolve this vector into two perpendicular components. Now I can draw a rectangle using this vector. මේ vector එකත් එක්ක මේ rectangle එකක් වුණා දෙන්න පුළුවන්. Suppose this angle is theta. This is R. Now, according to vector parallelogram law, the resultant of P and resultant of Q, should be equal to 1. They should be equal to 1. Okay. That means R means the resultant vector of P and Q. Resultant vector of P and Q according to this vector parallelogram. Okay. So as this vector is Q, this vector also Q both way. This side is Q. Consider this triangle, ABC triangle. Now AB length is equal to the magnitude of R. AB length is equal to the magnitude of resultant vector. AC length is equal to the magnitude of P vector. BC length is equal to the magnitude of Q vector. Therefore, if you can define or if you can take those two lengths, if you can determine those two lengths, then you can determine the magnitude of P and Q. Therefore, to determine the magnitude of P and Q, you have to determine AC and BC. If you can determine AC and BC, then you can determine the magnitude of two perpendicular compounds. Is that clear? If it is clear, please raise the hand. Okay. බලන්න පුතේ. දැන් මේක හොයන්න. You know this height now ABC. ABC is a right angle triangle. ABC is a right angle triangle. And you know AB length, that is R. Therefore, if you write trigonometric ratios with ABC length, then sin theta is equal this length BC, the opposite side over hypotenuse. Opposite side is BC pute, BC over hypotenuse AB. Therefore, BC side is equal AB into sin theta. AB into sin theta. BC means put a Q. BC means Q. That means Q is equal R sin theta. AB means R. Put a AB means R. BC means Q. Therefore, Q, that means opposite side, this side is equal, Q is equal R sin theta. Q is equal R sin theta. Then you can write an expression for cos theta. If you write expression cos theta is equal adjacent side AC over hypotenuse AB. Therefore, adjacent side AC is equal AB cos theta. AC is equal AB cos theta. AC means P, that means P is equal R cos theta. P is equal R cos theta. Look at this one. That means if you resolve this component, the adjacent side to this angle is equal r into cos theta, and this is the opposite side. Opposite side is equal r sin theta. R sin theta. Therefore, if you are given this kind of vector to resolve, if this angle is theta today, if this angle is theta, then if you resolve this vector into the direction of this angle, may angle එක පැත්තට මම resolve කරොත්, that component is r cos theta. R cos theta, because this is the adjacent side. This is the adjacent side to this angle. Therefore, it is equal to r cos theta, and this component is r sin theta. This component is r sin theta. This component is r sin theta. Therefore, okay, this vector r, this one is equal, these two vectors, these two perpendicular vectors together. This vector r is equal to r cos theta vector, into this side, and r sin theta vector in this side. R sin theta vector into this side. Therefore, you have to remember this thing when you are representing a vector by its perpendicular components. These two perpendicular components should be at the same point. And එකම point එකක් මේ add කරනවා. එකම point එකකින් අපි මේක කරේ. එකම point එකකින් තමයි අපි මේවා resolve කරේ. Therefore, these two vectors should be at the same point. And other thing is, definitely there should be two components. Is that clear? If it is clear, please raise the hand. තේරෙනවද පුස්සා? Okay, now you can note down this thing. Okay. Have I finished? Have I finished, Ravi? කතා කරන්න බෑ. කෙලින්ම අර ගොළු කඩවටවත් ගියාද? හරි. හරි. Okay, we can do some examples today. Look at this one. Now, you are given 100 Newton force and this angle, the horizon, this force is uh, created 60-degree angle with the horizon. So you have to resolve this force into horizontal and vertical directions. Horizontal and vertical direction. Therefore, now this is equal to horizontal component. The horizontal component means it is the adjacent side with this angle. It is the adjacent side with this angle. So adjacent side is equal cos. It is equal cos. Therefore, the horizontal component should be R means 100 to the 100 cos 60. The vertical component, the other component should be 100 sin 60. 100 sin 60 means root 3 over 2. Root 3 over 2 into 100 means 50 root 3. 50 root 3. Therefore, into upward direction, 50 root 3 Newton is there. Into horizontal direction, cos 60 means half. 100 into half means 50 Newton. 50 Newton is there. So 100 Newton is into this direction. 100 Newton into this direction is equal to 50 root 3 Newton in vertical direction and 50 Newton in horizontal direction. So those are the resolved component of 100 Newton force. Is that clear? If it is clear, please raise the hand. This is one example. Suppose you are given more than one vector. If you are given more than one vector, that is called a vector system. System of vectors. If you are given more than one vector, that means it is a vector system or system of a vectors. So if you are given more than one vector to resolve, suppose this is x direction and this is y direction. Suppose you are given 100 Newton vector, this angle is 30 and 50 Newton. 50 Newton, this angle is 30. Sorry, no. This angle is 50 root 3 Newton. This angle is 60. And this angle, this This is 25 Newton. Now there are three forces. Three forces. One is into this direction, 100 Newton. Other one is 50 root 3 Newton, 50 root 3 Newton, 50 root 3. This one is 50 root 3. This one is 50 root 3. 50 root 3 Newton. And this one is 25 Newton. It is into the downward direction. Now you are asked to resolve this vector system into x and y directions. That means you have to resolve this vector system into x and y direction. That means, Puti, now there are three vectors now. Resolving vector into x and y direction means you have to reduce this vector system into two perpendicular vectors which are in x and y direction. Okay. Now we can determine how to do this. Okay. So before that one, actually I will take this one as third example. Before this one, I will let you know the second example. Now you are given a vector into vertical direction. Now you are given a vector into vertical direction. So you are asked to resolve this vector into 90-degree angle. 90-degree angle. Now this is horizontal. So if you take a resolve component into 90-degree angle, that means into this way. If you resolve this one, now this angle is 90 degree. Therefore, this component should be, now this is the angle, direction of angle today. Therefore, it should be 100 cos 90. It should be 100 cos 90. You know, cos 90 means 0. Cos 90 is 0. Therefore, definitely there should not be any resolve component put into that direction. Therefore, resolve component should be 0. That means if you want to resolve a component, if you want to resolve a vector into a perpendicular direction, you cannot do it. If you resolve a vector into perpendicular direction, then the resolve component will be 0. What is the meaning of this one? That means this vector will not affect that vector. That vector does not affect in perpendicular direction. අපි ගත්තොත් vector එකක් පුතේ ඕනම vector එකක් යාගේ perpendicular direction එකට effect එකක් කරන්නේ නැහැ. යාගේ perpendicular direction එකට effect එකක් කරන්නේ නැහැ. නිසා ආවට මෙයාව resolve කරන්න ඕන නම් perpendicular direction එකට perpendicular direction component එක 0 වෙනවා. perpendicular component එක 0 වෙනවා. ඒක ඇත්තටම තේරුම්කුත් නැහැ නේ. that is ඒක meaning එකක් නැහැ නේ. මොකද මෙයා තියෙන්නේ කොහොමත් මේ vertical direction එකට. එතකොට යාව ආයසරයක් horizontal vertical direction දෙකට මේ resolve කරන්න බැහැනේ. මෙයා ඉන්නේ කොහොමත් vertical direction එකට. එහෙනම් මෙයාව ආයසරයක් horizontal සහ vertical කියලා direction දෙකකට resolve කරන්න බැහැ. මොකද මෙයා කොහොමත් vertical නේ. එතකොට vertical component එක මේකම තමයි. يعني vertical component එක එකම තමයි තියෙන්නේ වෙනසක් නෑ. එතකොට horizontal component එක 0 වෙනවා. නේ? ඒක අපිට ගන්න පුළුවන් මේකෙන්. That means if any vector is resolved into a perpendicular direction, that component will be 0. The meaning of that thing is a vector, any vector does not influence in perpendicular direction. It does not influence. It does not influence to its perpendicular direction. Is that clear? If it is clear, Please raise the hand. Therefore, I can write therefore any vector does not influence perpendicular direction. මට මෙතෙන් ඕනේ මෙන්න මේක නිසා මම මේක දුන්න කෙලින් මේක ඒ විදිහට එතකොට එයාගේ x direction එකට resolve component එකක් නැහැ නේ x direction එකට resolve component එකක් නැහැ හරි suppose if you are given this kind of vector system definitely if you are given this kind of vector system to resolve x and y direction, definitely you have to resolve each and every vector in x direction and y direction. You have to resolve each and every vector in x direction and y direction. In x direction and y direction. So if you resolve vector 1, this is vector, if this is vector 1, in x direction, there will be a component. In y direction, there will be a component. Okay, I want them. So if we resolve 100 Newton force into x direction, it is 100. Now, if you resolve into x direction, what will be the component? I need to answer. What is the component to x direction? What is the component? What is the component of 100 Newton force into x direction? Tell me the answer. No need to simplify. No need to simplify. Just tell me 100, whatever the trigonometric ratio. What is the component of 100 Newton force into x direction? Very good. Anita, Tarasha, Saranya, Yoshida. What is the component of 100 Newton force into x direction? No, man, this angle is 60. This angle is 60. So, sorry, 60, not 60, 30. This angle is 30, no? This angle is 30. Therefore, if you resolve this one into x direction 100, you are resolving this angle, you are resolving this into the direction of angle. If you are resolving it into the direction of angle, the component will be cos. Okay? 100 into cos 30. 100 into cos 30. 100 into cos 30. Is that clear? Okay? 100 into cos 60. 100 into cos 60. That's correct. With an angle like C, then with an angle like 60. Now this angle is 60. Therefore, 100 into cos 30. Is that clear? If it is clear, please raise the hand. They don't understand. මේ angle එක පැත්තටම resolve කරන්නේ හැම වෙලෙම cos. Angle එක පැත්තටම resolve component එක ගන්න හැම වෙලෙම cos. Angle එකට opposite direction එක resolve එක මේ component එක ගන්න හැම වෙලෙම sin. Angle එක පැත්තට cos. එකක් cos නම් අනිකක් cos වෙන්න බෑ නේද? අනික sin වෙන්න ඕනේ. හරිද? ඒ නිසා එකක් හොයාගත්තා නම් හරිය අනික හොයාගන්න පුළුවන්. Therefore, if this component is 100 cos 30, then it will be under sin 30. Therefore, if you resolve this vector, if you resolve this 100 Newton vector, there are two vector components. One is 100 cos 30. The vertical component is 100 sin 30. Is that clear? Is that clear? If it is clear, please raise the hand. Then on to sir. I had the line to sir. So if you resolve 100 Newton force, then you can remove it. Now you can remove it. Now you have taken it. You have taken it. Now you can remove it. Then resolve this vector, resolve this second vector into x direction and y direction. If you resolve this vector into x direction, what would be the component? Tackle again. 50 root 3. If you resolve 50 root 3 to x direction, what would be the component? Tackle again. I need answers from everyone. Then I can know me. May pattara resolve ini. Aage pattara the angle ke pattara. Tackle again. What is the resolve component of 50 root 3 into x direction? I need answers from everyone. Yes, very good, Putih. Others? Yoshida? Sarane? Tarusha? What is your answer? Correct, Kati. 50 root 3 into this direction. 50 root 3 into x direction. May pattara. May pattara. May pattara. Resolve me. May pattara. Sorry, the answer. Now it is resolve into the direction of angle. May angle like direction is resolve. Angle like direction is resolve not again. The cos 50 root 3 cos 60. 50 root 3 cos 60 into this direction. 50 root 3 cos 60. Is that clear? Right? May method. If it is clear, please raise the hand. You know what to say? Hello. Seven hello. එකක් විතරක් ගන්න බෑ හොඳේ එකක් විතරක් ගන්න බෑ you if you resolve this one you have to consider both components one is horizontal component other one is vertical component if you resolve this vector පුතේ you will be have a vector into this direction as well as into this direction upward therefore into upside there's another force now that is 50 root 3 sin 60 sin 60 50 root 3 sin 60 cos 60 and sin 60 now 25 is into downward direction therefore as we mentioned earlier we cannot resolve it into perpendicular direction it will be 0 therefore it has only a vertical component that is 25 that is 25 that is 25 is that clear because its perpendicular component will be 0 is that clear if it is clear please raise that they know to say now we have resolved this vector system into vertical direction and horizontal direction, y direction and x direction. But there are several vectors in this direction, therefore we can now simplify this one. We can now simplify this one. So if you simplify this one, 100 sine 30. 100 sine 30 is equal. Sine 30 is half. Sine 30 is half. Therefore, that is equal 50. This one is equal 50 Newton. Sine 60 means root 3 over 2. That means 50 root 3 into sine 60 means root 3 over 2. 2 to 50 will be cancelled out. 25. Root 3 into root 3 means 3 bouquet. 25 into 3 means 75. Therefore, this one is equal 75 Newton. Root 3 into root 3 means 3. 3 into 25 is 75. And now make us simplify. Then cos 30. Cos 30 means root 3 over 2. Root 3 over 2. Therefore, answer for this one is 50 root 3. Root 3 over 2 then 100 into root 3 over 2 means 50 root 3. Then here 50 root 3 into cos 60. Cos 60 means half. Okay, half. Half. You have to divide it by 2. That means this one is equal to 25 root 3 Newton. 25 root 3 Newton. So now there are two vectors 50 and 75 into upward direction, 25 is into downward direction. So you can simplify them. You can simplify them. Okay. 50 into upward direction, 75 into upward direction. That means together 125 into upward direction, 125 into upward direction, downward direction, that is 25. That's 25. Upward direction 125, downward direction 25. That means in upward direction there are 100 Newton force. There's 100 Newton force. Is that clear? If it is clear, please raise the hand. තේරෙනවද දුසන්? මේ තුන අපි simplify කරොත්, මේ තුන simplify කරොත් 100 Newton force into upward direction. Then 25 Newton force is in minus x direction. 50 root 3 Newton force is in positive x direction. Therefore, if you simplify these two, then definitely 25 Newton root 3 Newton force is in positive x direction. Is that cool? If it is clear, please raise the hand. තේරෙනවද සන්නේ? That means if you resolve this vector system into two perpendicular components, you can simplify, you can reduce the vector system into 100 Newton force into vertically upward direction and 25 root 3 Newton force into horizontal direction. If it is clear, please raise the hand. Thank you. Okay. Write first two examples only. Right? Only first two examples. Right? First two examples. Example वाले नहीं देखा था तुम्हें क्लियर नहीं पा तुम्हें क्लियर नहीं पा तुम्हें नहीं कमेंट किया तगड़ फॉलो नहीं कर Right? First and second. Right? First and second examples only. Don't write anything in the third example. I will give you it as a separate topic. Just write first and second examples. Me done. No? Have you written the first and second example? Have you done? Have you done writing? Okay, with you. There are a topic. There are a topic. Resolving of a vector system. 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 Okay. Then draw this one. Look at this one. So if you are given a vector system to resolve in two perpendicular direction, like x and y, definitely after resolving of those forces, you have to simplify of them. You have to simplify. Therefore, instead of doing in this way, we can do this one very easily. Now, how to do this? You can resolve every force in x direction first. Then you can resolve every force in y direction secondly. That can be interchanged. But you can resolve every forces in each direction separately and take the resultant vector in that direction. Actually, what you have done here, you have taken the resultant vector in y direction. Simplification means you have determined the resultant vector in y direction. Then you have determined the resultant vector in x direction. Okay. So you can do the same thing at the beginning. How to do this? You have to consider a direction. Suppose I have taken right hand side of x direction and take the forces or take the resolve component. Take the resolve component of each and every force into that direction. You have to take the resolve component of each and every force into this direction. Into this direction means if the resolve component is actually in that direction, it will be positive. If the resolve component is in opposite direction of the considered direction, if the resolve component is opposite to this direction, it will be negative. Okay. Then you can take the resultant vector in x direction very easily. Look at this one. So what is the resolve component? What is the resolve component of 100 Newton force into x direction? It will be 100 cos 30. It will be 100 Newton cos 30. 100 Newton cos 30. That is in this direction, therefore it will be positive. Then, what is the resolve component of 50 root 3 Newton into x direction? Now, it is in other way, that means it will be minus, therefore it will be negative 50 root 3 cos 60. 50 root 3 cos 60. 25 root 3 cos 9, that will be 0, therefore non-interactive. And that means now you can simplify. 100 cos 30 means 50 root 3. 50 root 3 minus 50 root 3 cos 30 means 25 root 3. 25 root 3. That means to this direction, there will be a force which is equal to 25 root 3 Newton. If it is clear, please raise the hand. තේරුණා තුස්සන්නේ? පැහැදිලි නම් තුස්සන්න. I will raise the morning one. Now, we can do the same thing in y direction. Why? I will take the upward direction as the positive direction, Therefore, if there's any resolve component in upward direction, it will be positive. If any resolve component is in downward direction, it will be negative. That is the meaning of it. Then, if we take 100 Newton force What is the resolve component into y direction? 100 sine 30. 100 sine 30. 100 sine 30. It will be positive because it is in upward direction. Then 50 root 3 sine 60. 50 root 3 sine 60. That also in upward direction. That also in upward direction. 50 root 3 sine 60. Then 25 root 3 is in downward direction. Therefore, it will be negative 3. It will be negative 25. Therefore, answer is in upward direction here. Whether in a 100 plus 25 minus 25. Sorry. 100. So 50 plus 7. 50 plus 75. 50 plus 75 minus 25. That means into upward direction there is a force 100 Newton. Therefore, now this vector system is reduced to two vectors which are in x positive x direction 25 root 3 Newton and positive y direction 100 Newton. Is that clear? If it is clear, please raise the hand. එක තේරෙනවා නම් උස්සන්න කොහොමද කරන්න කියලා. ඒ නිසා අපි කෙලින්ම මේ දෙක අරගෙන මේ විදිහට ගත්තා නම් වැඩි ඉවරයි. හරි. ටක් ගාලා ගන්න. ඔව් sorry මෙහෙම දාගන්න. මෙහෙම. When resolving a vector system, we have to resolve each and every force. We have to resolve each and every vector. We have to resolve each and every vector into the given directions. In such case, we can use the above method. But finally, finally, we have to simplify. We have to simplify, but finally, we have to simplify the resolved component of vectors. We have to simplify the resolved component of vectors in each direction. Therefore, we can use the following method. Therefore, we can use the following method to resolve a vector system. Therefore, we can use the following method to resolve a vector system. Number one, step number one, resolving all the vectors into x direction. Into x direction. Resolving all the vectors into x direction. Resolving all the vectors into x direction and take the vector sum. Resolving all the vectors into x direction and take the vector sum. Okay. Okay, I will repeat from that part. Sarang, magandang kiwi ka na. can anyone repeat the may sentence may I have that I have given previously बोले मैं कल दी पूरे sentence से repeat कर बोल कहा मटे के दाल मेरे पास देंगे क्या वो दूसरा है तारोश हम दीप आने में को बात है मीठा खादिन दीप में कर में मगद we have to simplify කියන word එකත් එක්ක දු අනේ word එකත් එක්ක දීපු sentence එක මොකද්ද we have to simplify the resolve component the resolve component we have to simplify we have to simplify the resolved component එහෙම දාගන්න we have to simplify the we have to simplify the resolved components resolve components of each force each vector of each vector of each vector each vector or each vector or every vector we have to simplify the resolved component of each vector in two perpendicular direction or two given direction in two perpendicular direction. Therefore, we can use the following method. Therefore, we can use the following method. Instead of the above procedure. Instead of the above procedure. Instead of the above procedure. මේකත් එක පොඩ්ඩක් කියන්න ඕනේ පුතේ මේ actually I will create another group as a tutor submission group පුතේ so you have to submit or you have to upload your note as well as your answer sheets of answer sheets into that group පුතේ and මට ළමයි කීප දෙනෙක් කියවනවා. තාමත් මට කීප දෙනෙක් මම ඔයගොල්ලන්ට කිව්වා මට පර්සනල් ඉවන්න කියලා මම තව ගෲප් එකක් හැදුවා තියෙන නිසා මට පර්සනල් ඉවන්න ළමයි ටිකක් ඉන්නවා. ගොඩක් හොඳයි. මොකද නෝට් එක අනිවාර්යෙන් ගෙවන්න. මොකද නෝට් එකේ ඔයගොල්ලෝ ලියාගන්නේ වැරදි තියෙනවා. හරි. when you are writing the note පුතේ there may be some mistakes. Therefore I have to correct that thing පුතේ. Therefore once after the class you scan your note and send that to me. මොකද නෝට් එකේ මොකක් හරි පුංචි හරි මිස්ටේක් එකක් තිබ්බොත් තනිකර සෙන්ටෙන්ස් එක වෙන මීනින් එකක් එන්න පුළුවන්. මොකද මේක සිංහල මීඩියම් ක්ලාස් එකක් නෙවෙයි ඉංග්‍රීසි මීඩියම් ක්ලාස් එකක් නේ. ඒ නිසා මොකක් හරි ඔයාලට වැරද්දක් වුණොත් හරි මම කියන දේ මොකක් හරි හුරු නැතුනොත් හරි මොකක් හරි දෙයක් වුණොත් එහෙම මේ අර ගලෝපෝල ලියන්නේ නැහැ කියන්නේ ලියෙන්නේ නැහැ. හරි. එතකොට මේ සමහර වෙලාවට වැරදි දෙයක් ලියවිලා තියෙන්න පුළුවන්. ඒ නිසා අනිවාර්යෙන් මට එවන නෝට් එක මට බලන්න. මොකද ඊට පස්සේ ඕගලන්ට ඔක අහුවෙන්නේ ඊට පස්සේ මේ ඕගොල්ලෝ පාඩම් කරන්න ගන්නකොට. ඔයාලා ස්ටඩි කරන්න ගන්නකොට ඔයාලා ස්ටඩි කරන්න ගන්නකොට මොකද්ද පුළි විදියට තියෙන්නේ කියලා හිතෙන්න පුළුවන්. හිතුණට පස්සේ ආයෙ වාට බලාගන්න විදිහක් නැහැ ඩේට් එක දන්නේ. ඒකට අදාළ රෙකෝඩින් එක කොහෙද තියෙන්නේ කියලා හොයාගන්න බෑ. ආයෙ මනාට හොයන්න බෑනේ කොහෙද රෙකෝඩින් එකක් වගේ. හරි. එකක් මතක තියාගන්න ඩේට් එක දාලා ලියා ගන්න. සාමාන්‍ය නෝට් එක ලියනකොට ඩේට් එක දාගන්න අනිවාර්යයෙන්. මොකද අඩු ගන්න ට්‍රේස් කරන්න පුළුවන් ඩේට් එක දැම්මට පස්සේ මොකද මාත් රෙකෝඩින් එකේ මගේ ඩේට් එක දානවනේ. රෙකෝඩින් එකේ මම ඩේට් එක දානවා මෙන්න මේ අවල් දවසේ රෙකෝඩින් එකේ. එතකොට ටග් ගාලා ට්‍රේස් කරන්න පුළුවන් වෙක්ටර් වල දවසේ ටග් ගාලා රෙකෝඩින් එක ට්‍රේස් කරන්න පුළුවන්. ඔයාලා රෙකෝඩින් එක ඔයාලා ඩේට් එක දැම්ම නැත්නම් එහෙම. හරි බැරි වෙලා හරි මට මිස්ටේක් එකක් වෙලා මට ඩේට් එක දාන්න බැරිනුත් හරි රෙකෝඩින් එකේ මම බලාට හොයන්න බෑ. හරි ඒ නිසා මේ පුරුද්දක් විදියට ඩේට් එක දාන්න. පුරුද්දක් විදියට අනිවාර්යෙන් මේක ඔන්ලයින් ක්ලාස් එකක් නෙමෙයි ෆිසිකල් ක්ලාස් එකක් නෙමෙයි ඔන්ලයින් ක්ලාස් එකක්. ඒක නිසා අනිවාර්යෙන් ඩේට් ෆිසිකල් ක්ලාස් එකක් වුණත් රෙකෝඩින් එක බලලා ට්‍රේස් කරන්න ඕන නම් අනිවාර්යෙන් ඩේට් එක තියෙනවා. නෝට් එක ලියනකොට ඩේට් එක දාන්න. You have to put the date. හරි. ඔව්. නැත්නම් ට්‍රේස් කරගන්න බෑ මොකක්ද උනේ කියලා. හරි. The first step is මොකද්ද? මම කිව්වේ resolving all the vectors into x direction and take the vector sum. Resolving all the vectors into x direction and take the vector sum. Second thing is resolving all the vectors into y direction and taking the vector sum. Taking the vector sum. හරිද? හරි. මම මෙතන ආයසය ලියන්නේ නැහැ මේක මොකද්ද මේ පැත්තට දැම්මම පස්සේ මේ පොසිබිලිටි එක ලියන්නේ නැහැ ඒක ඔලි තියාගන්න මේ you have to consider a direction Puti. You have to consider a direction. So if the resolve vector is in that direction it will be positive. If the resolve vector is in other direction it will be negative. Come on, දාගන්නකෝ. In this case we have to consider a certain direction as positive direction. In this case, we have to consider a certain direction as the positive direction. If the resolved component, if the resolved component, if the resolved component is in that direction, it will be positive. It will be positive. If the resolved component in the opposite direction, It will be negative. It will be negative. That will be negative. Okay, now you can write this. Make it this one. ඊළඟට පුතේ මම තව පොඩි නොටිෆිකේෂන් එකක් යන් තියෙනවා මට 26 කට්ටියගේ හීට් ලෙසන් එක පටන් ගත්තා 26 කට්ටියගේ හීට් ලෙසන් එක පටන් ගත්තා කාට හරි මම මේ ළමයි කිව්වද රික්වෙස්ට් කරා හීට් එක තමයි කාට හරි හීට් ලෙසන් එකට එන්න ඕන හීට් එක අපිට මුලින් කරන් කියලා ප්‍රශ්නයක් නෑ අපි කරමු ඊට කලින් කරන්න ඕන නම් ඔයාලට free of charge ඉන්න පුළුවන් ඒක ආයිසර කියලා අලුතින් ගන්න නැහැ මම online ඉන්න පුළුවන් ඒක අපි Sunday 6:30 to 10:30 යනවා එක ලෙසන් එකක් කරලා තියෙන්නේ ඒක ඕනනම් අරගන්න පුළුවන් නෝට් එක අරගන්න Sunday 6:30 to 10:30 තියෙන හැබැයි මම මුලින් notify කරන්න එන්න ඕන මම link එක ගන්න ඊළඟට light lesson එක අපි next Sunday next Tuesday පටන් ගන්නවා ඕනනම් ඒකත් මට කියන්න next Tuesday evening පටන් ගන්නවා ඒකත් අවශ්‍ය කට්ටිය ඉන්නවා නම් Okay. Once you complete writing, once you complete writing, take the tube, put it. Take the tube. Now there are questions based on resolving of vectors. Question number one. Question number one. Resolve the below vectors or vector system in x and y direction. Resolve the below vectors or vector system in x and y direction. There are 1, 2, 3, 4, 5, 6, 7, 7 questions. There are 7 questions. There are 7 questions in vectitude. In vectitude, these questions. Okay. You start to do them. So once you complete of doing these questions, you can take a small break. You can take a small break. Then we can join again to discuss them. After that, we will do some questions based on taking resultant vector of a vector system. Vector systems can have a Yeah, make it about 15 minutes. Okay, we can start our next session by 10:15. 10:15 එනකොට එන කට්ටිය. 10:15 එනකොට එන්න 10:15 එනකොට එන්න කියලා කියන්නේ break එකක් අරගෙන break plus questions. So the break plus questions. Break plus questions. Then after that we will start the next session at 10:15. 10:15.